Good day, everyone, and we are back again together. Your favorite uncle is back. And to all our grade 11s, I know that you are currently preparing for your exams or your tests. So let's get right into it. If you haven't subscribed, please just make sure you're part of the family. And of course, you can always get in touch with us. Our email address is info@mlungisinkosi.co.za. Of course, we do offer some private classes as well as other value-added services. Right, now let's have a look at this question. This I took from the 2018 exam. Yeah, that's grade 11. So let's have a look at it. So I'm just going to create some space here just to make sure that we've got some space to work in. Right, so first question, it says solve for x in each of the following. So we're not going to waste time with that. Okay, so that's 1.1.1. Okay, so in this case, we've got x into 2x, rather plus 1 is equal to 0. Now, please, ladies and gents, for this one, don't waste too much time. If you've got a 0 on the other side, there's no need for you to multiply inside the bracket. All we need to do is just give our solution. So in this case, it's already factorized for us. So it means that x is equal to 0 or 2x plus 1 is equal to 0. Okay, so that means that we've got 2x is equal to negative 1, and we can divide both sides by 2. And so x is equal to negative 1 over 2. Those are both our answers. All right, so please keep in mind, the only time we'll do that is if we've got a 0 on the other side. They've given us something that's already factorized, so we just get, in this case, the roots. Right, so the next one, we've got 5x squared plus 2x minus 6. Okay, so let's just create some more space here. Okay, so we've got, so that's 1.1.2. They've given us 5x squared plus 2x minus 6. And again, that is equal to 0. So they've already, plus 2x minus 6, yes. They've already given us that in standard form. So in this case, they said correct to 2 decimal places. What they are suggesting to you is that you are not able to factorize this. And so you're going to use the quadratic formula. So you're not going to waste time on this. As soon as they tell you correct to 2 decimal places, all we're going to do is use our quadratic formula. That's minus b plus minus the square root of b squared minus 4ac divided by 2a. Right, now note in this case, this is going to be our a value, our b value, and our c value. So a is 5, b is positive 2, and c is negative 6. Right, so I'm going to substitute that there. So that's minus a positive 2. Okay, that's plus minus the square root of b squared again, that's 2 squared, minus 4 times our a value is 5, and our c value is negative 6. Please don't forget about, those signs there. So that's going to give us divided by 2 times a, and a is 5. Okay, so let me continue to just give some space there. All right, so that's going to be, that's negative 2 plus or minus. Now, if you look at this, that's 2 squared, which is 4. So that's negative times that negative, that gives us a positive. 4 times 5 times negative 6, that gives us, that's 4 times 5, which is 20, times negative 6, that's 120, times that negative there, that gives us a positive 120 plus 4. So all of that, that's going to be 124. This is divided by 10. Okay, so in this case, all you simply do, so you've got minus 2 plus square root of 124 over 10, or x is equal to negative 2 minus the square root of 124 divided by 10. Okay, right, and all you do in this case, just whip out your calculator. Okay, in fact, let me just do this. take the fraction, so we've got minus 2 plus the square root of 124 divided by 10. Okay, so I get a value of 0.91. Please confirm that for me. Okay, remember they said to 2 decimal places. Okay, and we're going to do the same, so that's minus 2. Okay, so all I'm going to do is just change that to a minus. So I get negative 1.31. Okay, and so that is my other solution. All right, so I hope that made sense, ladies and gents. Okay, right. In fact, let me just try and move this as far away as possible. Okay, right, we'll get to that in just a bit. Right, so now we're looking at 1.1.3, which is an inequality, 2x squared minus 2 greater than or equal to 3x, right? So 1.1.3, that's 2x squared minus 2 greater or equal to 3x. Okay, right, so now we are going to try and work on that. So if you haven't watched our videos on solving for quadratic equations as well as inequalities, please do yourself that favor. Okay, so we're taking that, we must put it in standard form as a quadratic formula, right? So that's minus 2 greater or equal to 0, right? So we factorize. Please do watch our video on factorization. I've made it quite simple there. Okay, so that's going to be 2x and x. Okay, we're going to have 2 and 1 over there, right? And in this case, that simply means that will be negative and that will be positive. Right, so now we look at this and we say, right, what are our critical values? If you look at this, your critical values are going to be at negative 1 over 2. Remember, you put them as a number line. In this case, as I said, if you haven't watched our videos on, finding or on inequalities, please do yourself that favor. Right, and then we know this is going to be plus, that's minus, that's plus. If you don't know what this means, this comes from a quadratic or a parabola. In this case, it's positive for all values there, and it's positive for all values from 2 all the way to infinity. In this case, minus a half all the way to negative infinity. Now, what is our solution in this case? Simply means that this graph is positive. So x would be an element of negative infinity, right? So it's this area here, all the way up until negative a half. And by the way, because they said greater than or equal to, so it means we're going to include that value there. And in this case, we're going to say from 2, which is included, all the way to infinity, which is not included. Right, now in this case, ladies and gents, how you can also express this as an inequality is simply say x is less than negative 1 over 2, or x is simply greater than or equal to, and less than or equal to, because we've got that equal to there. Okay, right, I hope that makes sense. Right, now the next one. Okay, so they give us something that has to do with, first of all, surds, right? But secondly, you note that we've got 2 surds that are exactly the same, 2x plus 5, okay? Right, now, again, let's just make some more space there, okay? So we've got 1.1.4, the square root of 2x plus 5, okay, that's minus 3 over the square root of 2x plus 5, which is equal to 2. I think it was negative 2. Let's just verify that again. Yes, so that's minus 3 rather. Okay, yeah, I think that's fine. Right, now what are we going to do? Let's let square root of 2x plus 5 equal to k. Why am I doing that? Because I've got similar expressions there, right? So I'm going to substitute that for k. So I'm going to say, right, so that's going to be k minus 3 over k, which is equal to negative 2. So what do we do in this case? We're going to actually multiply by the lowest common denominator multiplied by k, so that we can get rid of that k at the bottom there, right? So if we multiply by k, I want to use a different color there. So if we multiply by k on the left-hand side, okay, we have to multiply by k as well on the right-hand side. Okay, so what do we have? K times k, that's going to be k squared. K times negative 3 over k, that would be negative 3 because the k's cancel, which is equal to negative 2k. Right, so we've got k squared minus 2k minus 3, or actually plus 2k minus 3, which is equal to 0. Okay, so let's open those brackets there. That's k and k. That's going to be 3 and 1 in this case. Okay, that's going to be plus and minus. Of course, I'm going through this very quickly because I'm assuming that you would have watched our videos on factorization, right? So k is equal to negative 3 or k is equal to 1. Now, let's evaluate in this case. Remember, what is k? It's that positive square root, right? So that positive square root cannot give us a negative value, right, as an answer. So in this case, it means this value is not applicable, but in this case, definitely it means that 2x plus 5 would be equal to 1. Now remember, we were not solving for k, we were solving for x, right? So what are we going to do? Square both sides, right? So going to square this, and as a result, so I am going to have, so that's 2x plus 5 equal to 1. So 2x is equal to, so if I take this to the other side, that's 1 minus 5, that gives us negative 4. And so x is equal to, so divide both sides obviously by 2. And so x is equal to negative 2. Okay, so again, you can go there and check if that is actually plausible. Is it possible that x can be that value, right? So let's substitute negative 2 into that. 2 times negative 2 plus 5, okay? So that's going to give us 1, right? And we said on the other side, that's going to be equal 1. So if you say negative 2 times 2, that's going to be negative 4 plus 5, that gives us square root of 1, which is actually 1. So it means that this value is actually, in this case, our solution. All right? So I hope that makes sense thus far. Right, so let's go on to the next portion. So now we are looking into solving for x simultaneously, right? So they say solve for x simultaneously. So let's do that very quickly. So we've got y plus x is equal to 2, as well as x squared plus 3xy plus 8, which is equal to 0. Now, all you simply do, ladies and gents, you call this equation 1, you name this equation 2. So what are we going to do? So y would be equal to, so from equation 1, actually I should say, from equation 1, I'm making y the subject of the formula. Make the one that is simplest the subject of the formula. That wouldn't give you fractions, right? But if they both give you fractions, there's no avoiding that. So y is equal to 2 minus x. Let's call that equation 3, right? Now, equation 3, I cannot substitute it back into equation 1 because it comes from equation 1. So I'm going to say, well, substitute equation 3, right, into equation 2. So it means everywhere I see y, I am actually going to just substitute 2 minus x. So this is going to be x squared plus 3x times 2 minus x plus 8. Okay, right. I feel like I've missed. Okay, yeah, I think I've got everything there. And this is equal to 0. Right, so what do we have? We've got x squared plus 6x, 3x times 2, and 3x times negative x, that's minus 3x squared, plus 8, which is equal to 0, right? So in this case, what do we have? We've got x squared plus 6x minus, oh no, actually, I see I've made a mistake there. So you've got x squared minus 3x squared, which gives you negative 2x squared plus 6x plus 8. And this is equal to 0. So I'm going to divide throughout by negative 2 because all of them are factors of 2. So I've got x squared minus 3x minus 4. And this is equal to 0. Right, so as we substitute, or rather as we factorize, so that's x and x, that's 4 and 1. Okay, so that would be negative, that would be positive. So x is equal to 4, or x is equal to negative 1. Now remember, we're solving for x and y. So I'm going to substitute my answers back into equation 3 so that I get the corresponding values of y. Right, so it means that now substitute for x is equal to 4 or x is negative 1 into equation 3. So y is equal to 2 minus a positive 4, or y, okay, is equal to 2 minus a negative 1. So in this case, that's going to be negative 2. Y is equal to 3. Right, so those are our answers. We've got both values of x and y respectively. Right, okay, let's go to the next one. So we're looking at nature of roots, right? They say the roots of the equation f of x is equal to x. In fact, you know what? Let's take this down so that it's easier for us to work with. We don't keep having to scroll back up. Right, so now they say to us we've got the roots, which are that. So they say determine the values of m for which the roots will be non-real. Now remember, when are we going to have non-real roots? We will have non-real roots when this expression here, that is underneath the square root becomes negative, right? So if our expression in this case becomes negative, then we know our roots will be non-real, okay? So what are we going to do? We're going to say, right, so first of all, so 16, okay, minus 4m into negative m plus 5, right? In order for it to be real, this expression must be greater than 0. But we want the roots, we want to know when will they be non-real. They will be non-real when this expression becomes less than 0. And please note, not less than or equal to, but simply less than 0. So let's try and solve. That's going to be 16 plus 4m squared minus 20m, and this is less than 0, right? So we've got 4m squared. We're putting it as a quadratic formula, right? Equation. So that's going to be 4m squared minus 20m plus 16, which is less than 0. Okay, we're going to divide everything by positive 4. It will not affect the inequality. So that's going to be minus 5m plus 4, which is less than 0. So now our critical values, so we've got m minus 4, m minus 1, okay, value of x, or the constant is positive there, so it means that our brackets have the same sign, okay, so, and our sign in this case is negative, right? So we've got m minus 4, m minus 1, so let's put that as a number line. The smallest value is 1, and the other one is 4, right? So we know we've got positive, negative, positive there. So when is this expression less than 0? It will be less than 0 for these values here. So we know our solution, therefore, is x must be an element of 1, between 1, remember, that is not included, right? And 4, which is not included. If you haven't watched our video on inequalities, please do yourself that favor. So x, actually quadratic inequalities, not linear ones. So x would be an element of 1 to 4, and both values would be excluded. I hope that makes sense, ladies and gents. That is how we would get non-real roots from that expression. Right, and so the last one, they say show, oh, and by the way, please note that we've got m at the denominator there, so m cannot actually be equal to 0. M must not be equal to 0, okay? Right, so they say show that the maximum value, so we're on 1.4 now, show that the maximum value of that expression, minus x squared plus 4x plus 12, is 4. Now, we've got an expression there, minus x squared plus 4x plus 12, right? And they want us to prove that the maximum value in this case would be 4 rather. Right, now, I want us to note this very quickly, right? That's 1.4, so I just wanted the number so that we know which one we're working on. Right, so what is inside that square root is a quadratic expression, right? Now, if you've gone through, in this case, the parabola, okay? So we know this represents a parabola. So when is a parabola at its maximum value or minimum value? In this case, it would be maximum because you can see that the value of, or the coefficient of x squared is negative, a greater than, less than 0 rather. And so that means it's a sad parabola, meaning that we've got a maximum value. Now at the maximum value, where do we get the maximum value, right? We get the maximum value of the parabola at the turning point, right? So how will we be able to get the turning point in this case? Remember, we always get the turning point by simply saying that's minus b over 2a. That gives us the x value of the turning point, and we can find out what is the actual y value of that turning point. So let's find the x value first. That's x is minus b. Okay, we're looking at that expression inside, right? We know our a value is -1, our b value is 4, and our c value is 12, right? So we're going to say that is minus b over 2a. So that's negative, our b value is 4, divided by 2 times our a value is -1. So you've got -4 divided by -2, and it means that your x value at the turning point would be equal to 2. Okay, now we're going to take that value and find the turning point, right? So it means, imagine we're finding the y value of that turning point there, and our expression is x squared plus 4x plus 12. Okay, sorry for writing it at the bottom there. Right, so that's 2 squared plus 4 times 2 plus 12. Okay, so you've got negative 4 plus 8 plus 12. Okay, so that and that gives us 20 minus 4, that gives us 16, right? So the corresponding y value in this case would be at 16. But remember, they've given us a square root. So it means the turning point would be at 16, but we're not looking for just any turning point. We're looking for the square root of that turning point in this case. So it means that our maximum value would be equal to at square root 16, which is equal to 4. I hope that makes sense, ladies and gents. And that is a wrap when it comes to this section, and I hope that when you guys practice, you're going to actually master this section. Otherwise, I'll see you guys next time. Don't forget to subscribe and like, and of course share to as many people as possible. Otherwise, from me for now, I'll see you guys next time. Sharp sharp.